Okay, we are doing complex fractions. Steps to complex fractions is to make one nice fraction on top, one nice fraction on bottom. I'm going to explain what that means here in just a second. And you're going to treat them separately at first, okay? When you look at this all together, yes, it looks overwhelming. And then I want you to realize, y'all, what does a fraction represent?
Dividing.
Dividing. So I want you to realize fractions equal division. So all we're doing is dividing. So you're going to write it as division, which I'm going to show you kind of how to skip that step. Flip the second and multiply, order, GCF factor, cancel, simplify as much as possible. So really, y'all, we're mixing up the last two practices. Okay? You're going to have multiplying and dividing. You're also going to have a little bit of addition and subtraction. So in the first two, there's no addition and subtraction because I want you to realize, if you look here, do you see how we already have a full fraction? Like, that's only one fraction, right? So I don't need to make it one fraction. It already is one fraction. So step one on this one, single fraction, is already done. But if you look here, do you see how that's a fraction? And technically, this is also a fraction. So we have to make that a single fraction. That's what step one is saying. So we'll talk about that in a second. So look in here. Step one's already done. So then it says to write it as division. So that's like putting it like this. Well, what do we do when we divide? Flip it and multiply. So, what's the only piece here that factors? The x squared minus 4, because it's a perfect square minus a perfect square. What squared gives you x squared? And what squared gives you 4? So this becomes x minus 2x plus 2. So I'm going to rewrite this as x plus 2 on top, x minus 2, x plus 2 on bottom. I'm going to change it to multiplication, and I'm going to flip. So this becomes x minus 2 over x. Now, I've had some people still putting a division sign in the middle. Y'all, we're not dividing anymore. We changed it to the reciprocal, so we're no longer dividing. If you put a division sign, I will take a point off. Okay? You changed it to multiplication because you flipped the fraction. Yes? You did the reciprocal. Okay, so now what do we do? Yeah, we simplify. We cancel what we can cancel. What can we cancel? X plus 2, x minus 2. Anything else? So what are we left with? And where is that x? On the bottom. So where does that x have to stay? On the bottom. Now, what can I put on the top that doesn't change anything? 1. Because technically, when I canceled this, that equals 1. Anything divided by itself equals 1. So what do we do if everything cancels? What does it equal? It's 1. Okay? So here's my answer. Do not tell me x. X and 1 over x are different. That's like saying 2 and 1/2 are the same. Okay? If you have $2, is that the same as having 50 cents? No, because 50 cents is half of $1. It's not the same thing. So x and 1 over x are very, very different. So make sure what's left, if it's on the bottom, it stays on the bottom. If it's on the top, it stays on the top. Yes? Any questions with that? Okay, number 2, we're not going to go all the way through it. I just want to have a conversation because it's a simpler one and it's almost exactly like number 1. So I want you to realize we have a single fraction on top, but do we have a fraction on the bottom? So what do we do to make it a fraction? Over 1. So when I set this up, I have x squared minus 9 over 3x. Now, I don't have to write it as division. I can flip it to multiplication right away and just put the reciprocal right away. So 1 over x plus 3. Then I could factor and simplify, right? Okay, so if you want to skip writing it as division, you can. Yes? Okay, just make sure you flip the denominator. You have to do the reciprocal of the denominator. Do not flip the top. You'll get the wrong answer. Any questions with that one? Okay, we're not going to go all the way through. That's not your final answer. We're just not going to finish it. Yes? Okay. Look. Oh, yeah. I just put not finishing. Okay, so look at number 3. So this is one of the ones that's a little different. So we on this one, we need to make the top a single fraction. So this is where the addition and subtraction, the last 2 days of practice and notes, comes into play. So again, we're ignoring the bottom, because when you look at this all together, it's overwhelming. Okay? But if you think about just the top, it's one of the simpler problems from like yesterday and the day before. So what is my common denominator? What can I make it be? 7. This is 1 and this is 7. We can't turn 7 into 1, but we can turn 1 into 7 by multiplying, right? So times 7 times 7. Okay, so I have a common denominator of 7 now, so I'm going to write it as a single fraction. What's 7 times x? Minus x. Well, are those like terms? Yeah, what's 7x minus x, or 1x?
6x.
Yes, so 6x over 7. So that is our top fraction. So I'm going to use the black line to represent the fraction bar between the two fractions. Okay, so now let's look at the denominator. Cover up the top. We have x plus x over 14, which again can be x over 1. What is going to be our common denominator? What's our LCD? 14. So this is already 14, so that doesn't change. Over here I have to multiply by 14, top and bottom. So my LCD is 14. What's 14 times x?
14 x.
Plus, that doesn't change, so it's just x. Are those like terms?
Yeah.
What do I get? So now I have them fully simplified. So now we are going to rewrite it and simplify if possible. Yes? So I have 6x over 7. Change it to multiplication and use the reciprocal. So 14 over 15x. The denominator, yeah, it's always going to be division for complex fractions. So what cancels right away without simplifying? The x's, because there's no plus or minus in between. Remember, those are their own factor. This is a factor, this is a factor, this is a factor. Factor, factor, factor. There's no plus or minus, so none of them are stuck like glue together. So the x and the x cancel. Okay? Now, you could type this in your calculator, 6 times 14 over 7 times 15. I'm also going to show you a way to simplify on your own. So sometimes in college they don't let you use the TI-84s. So I want you to realize that 6 is the same thing as what? What multiplies to give you 6? 2 and 3. So 2 times 3. 14 is the same as what? 7 and 2. 15 is the same as what? And then 7's prime. There's no point in using 1 in itself. Okay, that doesn't change anything. So there's what we have. Now, what cancels? Well, the 7's cancel. What else cancels? The 3's. No, the 2's don't. Why don't the 2's cancel? Because they're both on top. Remember, it has to be top versus bottom to cancel. So what's 2 times 2?
1.
And what's left in the bottom?
5.
Now I'm going to show you. If you did this in the calculator, alpha y equals enter, you would have done 6, I know I crossed it out, times 14 over 7 times 15. And did we get the exact same thing? Yes. So that's an easier way to simplify if you don't get to use like a TI-84 eventually in whatever you do after high school. Yes? Okay. Because if you, now they get to use calculators, they just don't get to use graphing calculators. You can't make it a fraction and stuff like that. So if you multiplied 6 times 14, you're going to get a huge number, and it's going to be harder to come up with your factors. So you don't want to multiply first. You want to break them down first, okay, if you're doing this trick. However, in my class, can you use the calculator? Yeah. If possible, yeah. Now, if you have like a bigger number that can be broken down further, but it has the same thing on the bottom, you don't have to keep going because it'll cancel. Yeah. Okay. Number 4 we're not going to do because it's just a lot like number 1 and number 2. And I'd rather focus on the ones where you have to change them. So flip to the back. We have 3 more. Because those are the simpler ones. You don't have to change anything. You literally just flip and multiply, which we've spent 2 days on that. So I'd rather focus on this. Okay, so looking at example 5. What do you think our common denominator is going to be? X. Well, the only one that's a fraction is this guy. These are not fractions, so I have to make them fractions by putting a 1 underneath. And the best part about 1 is you can turn 1 into anything, right? So if this is an x, I know I can make this an x by multiplying by x. So times x on top and bottom. Same concept, times x on top and bottom. And I'm going to rewrite it now. Now they have a common denominator. What's my common denominator? X. Okay, what's 3x times x? Minus 5 times x is minus 5x. And then the 2 doesn't change because it already had x as the denominator. So the black line represents my middle fraction line. So the nice thing is this one's very, very similar. So again, times x, and we get 3x squared plus 10x plus 3 all over x. Any questions with what I've done so far? Now, I'm going to tell you right now, this one's not pretty. How would you have to factor those two tops? The box. You have to go all the way to the box. Why? Yeah, because a is 3. So I'm going to actually factor them for you because at this point we've been factoring since when? Yeah, since January. Also, since the day we got back from Christmas break. So I'm going to factor them for you. If you need help with factoring, though, make sure y'all are asking during practice. Yes? Okay. So my this factors to x minus 2, 3x plus 1, and my denominator is x. And what am I going to do? Change it to multiplication and flip the denominator. So what goes on top? X. And then my denominator is going to be that top factored. So factored is x plus 3, 3x plus 1. So I factored them for you. Any questions so far? You good? Okay. Okay, so what can I cancel? The 3x plus 1. What else? The x. I always use a squiggle to cancel x's because if you're like me and you draw a dash, it just still looks like an x. So make sure when you cross those out it's obvious. So what's my answer? Yep. Now that those are the only factors left, do I have to use parentheses? No. What if there was another factor left? Would I have to use parentheses? Yes. Y'all, if you write your factors like this, what does that look like that says? That looks like it says x plus 23x plus 1. Is that what that said? No. If you do not use parentheses, it's wrong. Okay? Now, that's when there's multiple factors. We only had one factor left, so we don't have to use parentheses anymore. However, if you used them, are you wrong? Like if I put these parentheses, is that wrong? No, it doesn't matter. Any questions on this one? Okay, so I want you to start looking at 6, and I want you to look at the top. Just the top, ignore the bottom. What do you think your LCD is, your least common denominator? So this one's a little weird. A lot of people want to say a plus 1. Is that what anybody thought? Okay, because this one has an a, that one has an a plus 1. However, when you make a common denominator, you have to multiply. Can you multiply to add a plus 1? No, that's adding. You see what I'm saying? So you can't do it that way. So these are factors. It's not the same as when you have numbers like 2 and 3. Okay, when you have letters, you're pretty much just going to multiply them by each other if they're fully factored. So, get a different color. I have a plus 1 and a. Well, this one has an a plus 1. Does this one have an a plus 1?
No.
No, so it needs an a plus 1. What I do to the denominator, I have to do to the numerator to keep it equal. So now their a plus 1's match, but what does this one, the second one, have now that the first one doesn't? The a by itself. So this one needs an a by itself also. So my LCD, here's my middle fraction bar, is a parentheses a plus 1 and I have to multiply. Well, what's a times 1? 1a. Or is it okay if I just put a? Yes. Now, what symbol's in the middle? Minus. I've told y'all this whole time to bring up the minus so you can distribute it together, yes? So negative 1 times a is negative a. Negative 1 times positive 1 is negative 1. Are there any like terms? What can I simplify on top? The a's. What's a minus a? Nothing. It cancels. So I have negative 1 over a plus a. Or a parentheses a plus 1. Sorry. And then my denominator, is that already a single fraction? Yes. So that's just 1 over a. Doesn't change. So we like that one. So I'm going to rewrite this top fraction. I have negative 1 over a parentheses a plus 1. Change it to multiplication. And flip my denominator for my reciprocal. What cancels? A's. Okay, so then I have, negative 1's all by itself, so I have negative 1. What's a plus 1 times 1? A plus 1. Does anything change when you multiply by 1? No. So we have this. However, you could also write it without the parentheses. It doesn't matter which way. Both are accepted. So you don't have to write it both ways, but I want you to realize you can put the parentheses, but you don't have to. Any questions with that one? Okay, one more, and this one is the confusing one. So bear with me. Okay, what's different about this one than the other ones? Almost.
Except for the plus and minus.
Yeah, there's no fraction on top or bottom. It's just one fraction. But what's different? Did the other ones have... Yeah, what's my exponent? It's a negative exponent. Okay, who remembers what a negative exponent means? We have to get rid of the negative, but who remembers how to get rid of the negative? Anybody? Yeah, kind of. So not necessarily flip it. Remember, it means that it's on the wrong side of the fraction. So watch. So I'm going to rewrite the top because I don't have room to make it a fraction right there. So I have 2x negative 1 plus 1. When you have a negative exponent and it's not already a fraction, you have to make it a fraction. Now, the reason I can't just move this to the bottom and that to the top of the fraction that's already there is because of the plus and minus. Those are stuck like glue. I can't just move things around like we used to do when we had no addition and subtraction. Since we have that addition and subtraction, it makes that stuff stuck. Okay? Which is what makes this more difficult than when we just dealt, like, their old problems that we used to do would look like this. Like 2x to the negative 1 y squared. You see how there was no plus or minus? And so 2x to the negative 1, like we could move that to the top and that to the bottom and had no issues, but there was no plus or minus. What we're doing now has plus and minuses, which makes it to the point where I can't just move that. I'd have to move everything, and that makes it not the same. So we have to get rid of the negative on the top. So when you have a negative exponent, it means it's on the wrong side of the fraction. So when I move it to the bottom, it looks like this, and it becomes a positive exponent. However, can I have an empty numerator? No. So what can I put up there that doesn't change anything? A 1. Now, 2x to the first power, is that the same thing as just 2x?
Yes.
Yes. So I can rewrite it like this. Now I need to make this a fraction, and what's going to be my LCD? 2x. So I'm going to multiply this side by 2x. times 2x. So my LCD is 2x. And I end up having 1 plus 2x. What needs to go first? The 2x. So I have 2x plus 1, because that's proper order. Okay, so now I drew that because that's where my bottom's going to be. So now I have this guy. Now this one's a little different. What's different about the bottom than the top? No parentheses. So what I want you to realize is here the whole thing had a negative exponent. But here the 2 doesn't have a negative exponent. Only the x, because when there's no parentheses, it's only what it's touching, what it's to the top right of. So what's the only thing I'm going to move? The x. So when I rewrite it, I'm going to just move the x to the bottom. So what stays? The 2. So this becomes 2 over x to the first power minus 1. Now do I have to put that first power? Is that the same thing as just 2 over x? Yeah, so you don't have to put the first power, but it doesn't hurt anything. So I need to make this a fraction. What is my LCD? X. So I need to multiply this side by x times x. So my denominator is x. And what's the proper order to write this in? I have 2 minus 1x.
Negative 1x. Negative x plus 2.
Yes, or negative x. If you didn't put the 1, that's okay. So now we have this. The worst part of this problem is over. Okay, so I'm going to rewrite the top, change it to multiplication, and do the reciprocal. So I have x over, now I am going to take the negative out, okay, because I'm going to be proper. So if I take out the negative 1, what do I have left? Not plus. Yes, remember they both become opposite. So the opposite of negative 1x is positive 1x, and the opposite of positive 2 is negative 2. Because it's the same thing as dividing by negative 1. Now what cancels? The x's. Anything else? No. So we have a 2x plus 1 on top over, what's 2 times negative 1?
Negative 2.
There's your answer.